Hello everyone. Today's topic is convolution theorem. And remember, this topic is applicable only for inverse Laplace transform. Okay, not Laplace transform. So before starting the actual topic, convolution theorem, first of all, we have to know or we have to understand what is convolution. Convolution, this is an operator. Okay, a special type of operator using the concept of integration. Okay, so first understand the operator convolution. Okay, suppose we have two functions ft and gt. Okay, we have two functions ft and gt, and obviously these two functions are integrable functions. Okay, now we can apply the operator convolution between these two functions f and g, and this operator convolution, this is denoted by f star g. Okay, this is the symbol of convolution, f star g. Now what is f star g? This is equals to integration 0 to t f of u g t minus u du. Okay, f of u g t minus u du. That means this is the given function f of t. You have to change the variable t. Okay, so f of u. Now this is the given function gt. In place of t, you have to write gt minus u. For example, suppose f of t equals to sin x. Sin t. Okay, and g of t equals to cos of t, for example. Okay, so what will be f star g? F star g, that will be integration 0 to t. Here you have f of u, that means you have to write sine u. Okay, and this is gt minus u, then that means in gt, in place of t, you have to write t minus u. So that will be cos t minus u, and the integration is with respect to u. So this is the convolution operator. Okay, now if you integrate the this integration, you will get the result. Okay, this is the concept of convolution. Now question is, in inverse Laplace transform, how we can apply this operator convolution? Here you will be given two functions. Okay, first function is ft and gt. ft ft and gt. Okay, first you have to calculate Laplace inverse of f of t, and you will get f of s, and Laplace inverse of gt, this is equals to g of s. Clear? So Laplace inverse of f of t, this is equals to f of s, and Laplace inverse of Laplace inverse of f of s, because I am applying inverse operator, so that will be Laplace inverse of f of s, this is equals to f of t, and Laplace inverse of g of s, this is equals to g of t. Now if any function, this is the product of fs and gs. Okay, product of fs and gs, then we have to find out Laplace inverse. Clear? We have to find out Laplace inverse of the product of two functions fs and gs. In that case, we can use convolution theorem. Okay, so first you have to calculate Laplace inverse of fs, then you have to calculate Laplace inverse of gs, then obviously you will get ft and gt. Now apply convolution between ft and gt, that means f star g. And you know what is f star g? Integration 0 to t f of u g t minus u du. Okay, so again I am repeating. First you will be given a function of s, and that will be product of fs and gs. Okay, that will be in the form of product of fs and gs. So first you will be given fs gs product. Okay, and you have to apply Laplace inverse on this product fsgs, and the result will be nothing but Laplace inverse of fs, that means f of t, and Laplace inverse of gs, that means g of t, and convolution between the two functions f and g. Okay, convolution between the two functions f and g. And you know what is the convolution result? I already have written integration 0 to t fu gt minus u. Okay, let's understand using an example. The question is find Laplace inverse 1 by s plus 2 whole square s minus 2. Okay, 1 by s plus 2 whole square into s minus 2. So obviously you can see here this function 1 by s plus 2 whole square into s minus 2, we can break this function into two functions fs and gs. So let solution, let fs is equals to 1 by s plus 2 whole square. Okay, and gs, this is equals to 1 by s minus 2. Okay, I am taking fs is equals to 1 by s plus 2 whole square and gs is equals to 1 by s minus 2. Now question is, if I take fs is equals to 1 by s minus 2 and gs is equals to 1 by s plus 2 whole square, in that case can you solve this problem? Yes, you can solve it, but you have to take by which you can solve this problem easily. Okay, if I take fs is equals to 1 by s minus 2 and gs is equals to 1 by s plus 2 whole square. Okay, so okay, first suppose if you take gs is equals to 1 by s plus 2 whole square. Okay, in that case what will be gt? Gt means Laplace inverse of gs. So that will be, actually this is 1 by s plus 2 whole square. So that means this is e to the power minus 2t and multiplied by t. Okay, t e to the power minus 2t. This is your gt. Okay, and when you will apply the convolution, you will get a term that gt minus u. Gt minus u. That means you have to write this function t minus u into e to the power 2 into t minus u. That means this is quite difficult term. Okay, you cannot integrate this gt minus u. That's why I am taking the easiest function as g of s. Okay, you have to take the easiest function as g of s. Clear? So let's start. So first find out f of t. Laplace inverse f of s. This is equals to Laplace inverse 1 by s plus 2 whole square. Okay, so this is equals to, obviously here s is replaced by s plus 2. That means e to the power minus 2t. This is multiplied into Laplace inverse of 1 by s square. So this is equals to a Laplace inverse of 1 by s square. This is t. So you are getting t e to the power minus 2t. And this is your f of t. Similarly, calculate Laplace inverse of g of s. This is equals to Laplace inverse 1 by s minus 2. And this is equals to e to the power 2t. And this is equals to gt. So your f of t is equals to t e to the power minus 2t and g of t equals to e to the power 2t. Okay, you have to find out Laplace inverse of the product of fs and gs. Okay, so now Laplace inverse fs into gs. This is equals to, that means Laplace inverse 1 by s plus 2 whole square into s minus 2. This is equals to, according to convolution theorem, the result is f star g. And what is convolution? This is equals to integration 0 to t f of u, and you know f of t equals to t e to the power minus 2t, and g of t equals to e to the power plus 2t. So just f of u means u into e to the power minus 2u, okay, into gt minus u, that means e to the power 2 into t minus u du. Okay, in place of t you have to write t minus u. Now just simplify this. So this is equals to integration 0 to t. If I break this e to the power 2 into t minus u, so you are getting a term e to the power 2t. Yes or no? Here you are getting e to the power 2t, but integration is with respect to u. That means we can out this e to the power 2t, we can take out this e to the power 2t out of this integration sign. Okay, so I am taking out this e to the power 2t. So you are getting this is equals to e to the power 2t integration 0 to t u e to the power, this is minus 2u and this is minus 2u, that means e to the power minus 4u du. Okay, now integration by parts. So this is equals to e to the power 2t, first function is u, so u into integration e to the power minus 4u du minus integration derivative of u, that is 1, then integration of e to the power minus 4u, that will be e to the power minus 4u divided by minus 4 du. Okay, and the limit is integration 0 to t. Okay, then again integration. So this is equals to e to the power 2t into, here I have gotten this will be e to the power minus 4u by minus 4. Yes, so this is equals to e to the power u e to the power minus 4u divided by minus 4. Okay, minus e to the power minus 4u divided by 16, 0 to t. Okay, let me check again. So minus minus plus 1 by 4 and e to the power minus 4u, that integration will be e to the power minus 4u by 4. That means you are getting minus e to the power minus 4u divided by 60, and the integration limit is 0 to t. Okay, now upper limit minus lower limit. So e to the power 2t. If I put the upper limit, so this is t e to the power minus 40 divided by 4 minus e to the power minus 40 divided by 16. This is upper limit minus lower limit. If you put u equals to 0, so this part is 0. Okay, so minus minus plus, plus e to the power 0 means 1, so you are getting 1 by 60. Okay, just simplify this. I am taking common 1 by 16, so e to the power 2t divided by 16 into, so this will be here you have a minus, so minus 4t e to the power minus 40. Okay, and from here e to the power minus 40, and this is plus 1. Clear? So if I multiply e to the power 2t, so you are getting 1 by 16 minus 40 into e to the power minus 2t minus e to the power minus 2t plus e to the power 2t. Okay, and this is the answer. E to the power 2t minus e to the power minus 2t minus 4t e to the power minus 2t and divided by 16. Okay, this is the final answer. Okay, so I am repeating. In question paper, a function will be given which is the product of fs and gs. Okay, so first you have to identify which one is fs and which one is gs. Okay, so after getting fs and gs, you have to calculate ft and gt, then apply convolution. Clear? Let's solve another problem. Question. Using convolution theorem, evaluate Laplace inverse of s by s square plus 1 into s square plus 4. Okay, so here the function is s by s square plus 1 into s square plus 4. So first let's take fs is equals to 1 by s square plus 1. I am taking fs is equals to 1 by s square plus 1 and gs is equals to s by s square plus 4. Okay, I am taking fs is equals to 1 by s square plus 1 and gs is equals to s by s square plus 1. If you take fs is equals to s by s square plus 4 and gs is equals to 1 by s square plus 1, again that will be correct. Okay, so first find ft, that means Laplace inverse of fs. This is equals to Laplace inverse of 1 by s square plus 1. So this is equals to sine t. Similarly, Laplace inverse g of s. This is equals to Laplace inverse s by s square plus 4. So you are getting, this is the Laplace inverse of cos 2t, cos of 2t. Now Laplace inverse of product. So s by s square plus 1 into s square plus 4. Product means convolution. So f star g. So this is equals to integration 0 to t. You have to apply fu gt minus u. That means sine of u into cos 2 into t minus u. Okay, tu. So now integration. I will suggest you to solve this problem taking fs equals to s by s square plus 4 and gs equals to 1 by s square plus 1. That will be easier. Okay, just I am trying to show you that both process is correct. Okay, so integration 0 to t sine u cos 2 into t minus u. Now we have to integrate this. Let's solve it by multiplying half into 2. Okay, so next. This is equals to half into integration 0 to t 2 sine u cos of 2 into t minus u d. Clear? So this is of the form 2 sine a cos b. So obviously you can use the formula that 2 sine a cos b, this is equals to cos b, this is equals to sine a plus b plus sine a minus b. So obviously if you compare with this formula, so this u is our capital A and 2 into t minus u, this is your capital B. Okay, so let's calculate half into integration 0 to t sine a plus b, that means sine u plus 2t minus u, that means you are getting 2t minus u. Okay, plus sine a minus b. That means sine u minus 2t minus minus plus 2u du. So finally you are getting half into integration 0 to t sine 2t minus u plus sine 3u minus 2t du. Okay, so let's integrate this. So this is equals to half into integration of sine 2t minus u, that will be cos of 2t minus u. Actually this is minus cos of 2t minus u and divided by the coefficient of u is minus, so divided by minus 1. Okay, similarly sine 3u minus 2t, so this will be minus cos of 3u minus 2t and the coefficient of u is 3, so divided by 3. Okay, now integration limit is 0 to t. So if you simplify, so minus minus plus, so half cos of 2t minus u minus, so this will be 1 by 3 cos 3u minus 2t, integration limit is 0 to t. Now put upper limit minus lower limit. So upper limit is t. So if you put upper limit, so this will be half into cos 2t minus t, that means cos of t minus 1 by 3. This will be cos 3t minus 2t, that means 1 by 3 cos of t. Okay, and minus lower limit, that means 0. You have to put u equals to 0. So this will be cos of 2t minus minus plus 1 by 3. So this will be cos of minus 2t. Yes or no? If I put u equals to 0, so you are getting cos of minus 2t, and cos of minus 2t, cos of plus 2t, both are same. So I am writing cos of 2t. Okay, so next you have to simplify it. So you are getting half into, this is cos t minus 1 by 3 cos t. That means you are getting, I am writing here half into, so this is 1 minus 1 by 3, that means 2 by 3 cos of t. Okay, and this is minus 1 plus 1 by 3, that means minus 3 plus 1, that means minus 2 by 3 cos of 2t. Okay, so if I take common 2 by 3, so the final answer is 1 by 3 into cos of t minus cos of 2t. This is the final answer. Okay, first one. Find out Laplace inverse of 1 by s plus a into s plus b. First question. Second question. Find out Laplace inverse of 1 by s square into s plus 1 whole square. Okay. Third question. Try to solve this one. Laplace inverse of 1 by s square plus s square whole square. Okay, s square plus s square whole square. Okay, I am writing the answer also. In first question, the answer will be, for this, the answer will be e to the power minus bt minus e to the power minus at divided by a minus b. Okay, and in second question, the answer will be t e to the power minus t plus 2 e to the power minus t plus t minus 2. And this question will be lengthy and this is quite difficult. Okay, try to solve it. For this question, the answer will be 1 by 2 a square into sin 80 minus 80 cos 80. Okay, so try to solve these questions. If you have any doubt, so feel free to ask me in comment section. Thank you so much.